welcome to my channel. Today we are going to talk about physics. The word physics is so beautiful and it has the capacity of the universe in itself. I know you people will be laughing that what am I saying? But this particular chapter, that is physical world in the syllabus of 11th science, is of very much importance, though it is not asked in the question papers. Now, why is it so? Because this particular chapter is your first step to go to any branch of science. May it be chemistry, may it be biology, may it be astronomy, geology, oceanography, or anything. Physics is a fundamental science that will take care of all other sciences. So in this lecture, what we are going to talk about? We are going to talk about what is physics, what is the scope of physics, how is physics and society related to each other, and then we will see some of the fundamental forces of nature that drives us crazy. Okay, so let us begin. Before understanding what is physics, let us first understand how this subject physics has evolved. So, I will talk about a little bit about physics to you. We all know that when we wake up, what do we see the first? Of course, maybe the ceiling fan, the lights, or let us be very natural. So, the first thing that we see around us is sun. Okay, we see the sun rising, we see the sun setting. We see day and night. We see seasons. We see tides in the sea. Correct? What we see around us has always been making us more and more curious. Since ages, humans have been watching stars, watching sun, moon, planets each and around the earth. Okay, they have always been curious as to why some particular thing happens in the same way. Like for example, if I just leave the pen, it will fall down. So that is the question that human had always asked. Why? So physics is the answer to why. Any question that you asked. For example, if I ask you, why is this fan rotating in this direction? Answer to this why is in physics. If somebody asks me, why is my car riding in this way? Why is my car not riding so smoothly? The answer to that why is physics. Now, you might be thinking that why am I marketing physics so much? Why do I need to talk a lot about physics? It is because physics is related to all other branches of science, like physics plus chemistry. There is another branch which is known as physical chemistry. Similarly, physics plus biology gives another branch which is biophysics. There are so many other branches whose fundamental lies in this fundamental subject of physics. So, let us go back to the mother of physics, that is science in general. Today, we are going to talk about physics in particular, but science in general. So, what is science? Science is nothing but a systematic study of every event that is happening. For example, if there is a pendulum, okay, and I am suspending it like this, from this point, if I just hold a pendulum, up to this side and I'm leaving it from here. Okay, you know it will oscillate. Okay, so what a normal person will do? Will look at the pendulum, be happy and enjoy. But what a science student has to do? It has to find out what is the length of this. Correct? Why is it coming in this direction only? Why isn't it just staying here only? Correct? And how much time is it taking to come from this point to this point, then again to this point? All these questions are the basis of the systematic study of any event that is happening. And so, one can say that science is a systematic approach to understand any natural phenomena, any experimental phenomena that is occurring, and then we will find out the details. So, first is the system of study. Second is the details. So, these two things will give you the answer of why is it happening. Okay. And then we have prediction. So, prediction will answer how. How it will answer how? That somebody will ask you, do I have a pendulum of this length and this mass? How nicely it will flow? Okay, the answer to that how is again from physics. So, physics is that important to all of us that we have to be very careful in understanding it. Now, remember one thing, that for anything in science or anything in physics, there is nothing which is unquestionable. For example, if I tell you today that say gravitational constant G, okay, is constant. But tomorrow, if you have enough proof and if you have enough evidence, you can come and tell me that no ma'am, gravitational constant G is no more a constant, but it has some variation. It will change. If you go to Ahmedabad, it will be something different. If you go to Mumbai, it will be something different. If you go to San Francisco, it will be different. So, it is not that your teacher has told you that G is constant means it will remain constant forever. But to prove that G is not constant, you have to give various experimental proof, various theoretical proofs and various backgrounds. One other example, the speed of light in vacuum, that is C, which is 3 into 10 raised to 8 meter per second. But if tomorrow you go and measure the speed of light with some more sophisticated method and tell me that it is not 3 into 10 raised to 8, it is 3 into 10 raised to 10, I will have to believe you, but only when you have sufficient proofs. Okay. So, there is nothing which is unquestionable in physics. There is not an authority, okay, that this is it. There has to be no change in it. There is nothing like that. Okay. Now, the beauty of physics, okay, it lies in two things. One is the unification. Unification. And another is the reduction. I know these two words are either very simple for you to understand, because literally unification means uniting things and reduction literally means reducing it to very small components. But in terms of physics, how do we understand unification and reduction? So, For example, if an apple that falls down, a beautiful example that Newton had used, an apple falling from the tree, it falls on the ground. So it was that one simple act, okay, but what he discovered out of it was gravity. Okay, and this term gravity has united almost everything in the world. It has become so general that this gravity works for apple, it works for leaf, it works for stars, it works for sun. Of course, sun is a star. It works for galaxies. Okay, so this one simple invention, like we say, which had just come up from apple, okay, it has united almost many phenomena of physics, of general science. So this is the beauty of physics as far as the unification is concerned. Now next, let us go to the reduction. In reduction, what do? We don't look at this big events happening. We look at the smallest part and try to understand what is happening in the small part. And then we come back and try to relate in the whole event. Like, for example, take a simple rod, okay, which is, say, aluminium rod, okay, and I am heating the rod from here using a burner. Okay, and here I am trying to touch it with the hand. Okay, now while I am heating this part, what happens? Slowly this part where I have kept my finger, where I have kept my hand, it starts feeling hot. Okay, slowly the heat transfers from one place to another. But that is only when you have, say, a metal. But what if it is not a metal and it is a plastic? Yes, you are right. It will start melting from here. But it will not reach here. The heat will not reach. It will melt, burn. It will be distorted, this, that. And maybe if it catches fire some way, you will get heated. But the rod will not remain as it was in the case of metals. That means there is something what is different in plastic, which is very different from metal. So in the reduction, what we do is, we look at this small area, this small part, and see how my tiny teeny particles are behaving, how this one particle is giving heat to this particle, and this particle is giving heat to the next particle, and again it is giving heat to the next particle, so on and so forth. So I am reducing a big problem into a small part, trying to understand it in a small part, and then integrating it or extrapolating it into the entire system. So this is what is known as the reduction method in physics. Both unification and reduction are very important in terms of understanding physics. Okay. Now let us see how physics takes care of all the things in the universe. Physics take care of, again, two things: macroscopic world and microscopic world. Okay. Now what is a macroscopic world? The world that you and I can see with our naked eyes. All the activities that are happening on Earth, that we can see, we can feel, like a pendulum moving, or like a car riding, or like a bird flying, aeroplanes, all these events that can be easily seen, that can be touched, felt. Okay, these are known as the macroscopic quantities. Okay, then astronomy. Astronomical events, that is a star forming, the planet coming towards the earth, going away from the earth. Okay, the sun and the moon, take the tides that are happening, the gravitational interaction, all these things are considered in the macroscopic world. And other is a microscopic world, which takes care of atoms, nucleus, and molecules. Okay, those tiny things that you cannot see, that part of physics takes care in the microscopic world. So in the macroscopic world, we have different subjects like light, sound, electricity, magnetism, correct? And in this subject, we have atomic physics, nuclear physics. We study the structure of atom, we study the structure of nucleus, we see the interaction between electrons, protons, neutrons, correct? All these things are being studied in the macroscopic world. Now, just imagine what is the length of nucleus, or a radius of nucleus, you can say. It is of the order of 10 raised to minus 15 meter. Okay, this is so small. Okay, and now look at this astronomical phenomena over this side. How big can be the distance between the two planets, distance between two galaxies? What is the maximum length that you can have? It is 10 raised to 26 meter. So now you imagine that our beautiful subject physics takes care of the length 10 raised to minus 15 meter to 10 raised to 26 meter. Okay, so what is the gap in between the two? If you just imagine, this range is enormously high. Okay, now if I divide this length by c, what is c? C is the speed of light, which is 3 into 10 raised to 8 meter per second. Just forget 3 right now. Just take care of this part, 10 raised to 8. So if I divide this by 10 raised to 8 and this by 10 raised to 8. Okay, what comes? This, say 10 raised to minus 22 or 23, whatever. Okay, you can say minus 10 raised to 23 to 10 raised to 18 seconds. So if you look at this thing, you can come to some conclusion that this subject physics takes care of length ranging from 10 raised to minus 15 meter to 10 raised to 26 meter approximately. In terms of time, it takes care of 10 raised to phenomena that is happening in 10 raised to minus 23 second to 10 raised to 8 second. Okay, this 10 raised to 18, sorry, 10 raised to 18 second. Okay, and now what is the mass of electron? Electron is the smallest particle that we know right now. So in case of mass, 10 raised to 30, that is minus 30 kg to 10 raised to 55 kg. This is the mass of the known universe. This is the approximate mass of an electron. Okay. So if you see that this subject physics deals with three important parameters: length, time and mass. So it takes care of a long duration of time, a wide range of phenomena occurring at this length scale and even at this mass scale. Okay. So one can understand that the scope of physics, which was our second point which we wanted to study today, scope of physics. The physics has a scope in this broad band. So till now what we have studied, physics is a subject that studies nature, its evolution, its details and an answer to why and how. And the physics has a scope of this wide length, time and mass dimensions. Correct? So we have answered two questions for today. What is physics and what is the scope of physics? Now the third thing, that was physics and society. All the physicists who have studied physics in detail have done theoretical analysis, have done experimental analysis and have come out with some laws governing it, and finally that study has been developed into technology, and then that technology was useful for the society. So how it happens? Physics studies experiments and what develops technology, and this technology drives the society. Correct? For example, take an example of heat engine. Okay. Heat engine was studied as a subject of physics, which is known as thermodynamics, which we will come in next chapters. Slowly we will be introducing what is heat, what is energy, what is thermodynamics. But today, just believe that heat engine was studied as a part of physics, and this heat engine revolutionized the whole society, and it was converted into our steam engines, and what came out was industrial revolution. Okay. The moment heat engine was discovered, invented, put it into a technology, the whole society started using it, and the society progressed because of this fundamental study. Okay. Take a small example of X-ray machine. Again, back to physics. X-ray. What happened when X-ray was discovered? Yes, the structure of atom was known. The chemists started using it, and moreover, that is very common. You break your hand and you get an X-ray. Okay, you have some cough, you get your chest X-ray. Every medical uses X-ray has been put. So it was a fundamental study of physics, X-ray. It was converted into technology, and who used it again? Society used it. Okay, so this is our first example. This is our second example, and the third example is very common to all of you, because you are using that right now while I am talking to you. Yes, you are right. It is silicon. discovery and invention of silicon. Okay, revolutionized the technology and semiconductor chips. Okay, it has made a computer revolution. And let me tell you friends, this particular semiconductor chips which has revolutionized computer thoroughly, and today we are one of the leading manufacturers in this particular field. So this has given a lot of economic boost to a country. So back again, the research is done by physics. Physics is converted into technology, and technology goes back to the society. This is how the society and physics are interrelated. Before going to very simple topic, easy topic for you to understand, let me just give you one small example of how physics is going to be very useful for the whole society for coming all the generation. That is energy. We all know that energy, that is fuels, light, electricity, heat, thermal, whatever kind of energy you say, we are actually thirsty for energy. Our earth has nothing left actually to provide us as an energy source, and so there is a constant requirement of understanding, of gaining knowledge to find out some sources of energy. And yes, we have the nuclear energy, which promises to give us uninterrupted power supply for, say, infinity. And that is again, the basic fundamentals are physics, the fission energy, the fusion energy, and all the technologies that will be used in building up reactors to give us nuclear energy comes from the fundamental study of physics. So my friends, I think that you have gained a lot of imagination about physics. What I talked to you about for all this long time was not giving you a complete understanding of what physics is or how physics works, but it was to give you a glimpse of how physics is important and how nicely you can learn little concepts of physics, convert it into some usable technology and provide back to the society. That was the main aim. So this was the first part of the lecture, that is the physical world. In the next part, which will be a very small part, we will be understanding the fundamental forces of nature and how these forces are important to us and how these forces will be used for other applications in our own society. Fundamental forces of nature. Okay, there are 4 fundamental forces of nature, but first we will just study the 2 forces of nature, which is gravitational and electromagnetic force. Okay, our famous scientist Newton discovered gravity and gave us some understanding about the gravitational force. Okay, there are few points that has to be remembered. First thing, gravitational force is a long range force. Okay. Second thing, it is a universal force. Universal force which acts on every object having mass. Every object having mass will experience a gravitational force. Now, I have one small question. Can mass be zero? Is it possible? No. There can never be anything with zero mass, because mass is the amount of matter present, and you cannot have anything without a matter. So, mass can never be zero. So, the gravitational force will never be zero. Correct? Yes, of course, there are some equation F is equal to G m1 m2 by r square, and then again there is some vector form which we will come in the later chapters. Okay, this will give you the quantity of the force, but the type of force, the characteristic of force is given by this. On the contrary, okay, one more thing, it is always attractive. This force is always attractive. Okay. Now, let us go for the electromagnetic force. Electromagnetic force is also a long range force. It acts between the charges, that is positive and negative. Okay. Now, it can be either attractive or repulsive, depending upon whether it is between two like charges or whether it is between two unlike charges. It can be either attractive or it can be positive. But here mass cannot be zero, but yes, charge can be zero. So, it may occur that at some point there is no electric force, there is no electromagnetic force, but the gravitational force always exists. Okay. So, these are the two important long range universal forces that has to be taken care. And now, we have two other forces that we will consider. We have strong and weak. Both these forces are nuclear forces. Strong nuclear force and weak nuclear force. Now, the strong nuclear force acts between protons and neutrons. Okay, as we know that, for example, this is atom and this is the nucleus. We know that the electrons will be rotating in the orbit around the nucleus, and here we will have protons and neutrons inside the nucleus. So, when the protons and neutrons are inside the nucleus, this is the force that keeps binding. It will also act between protons and protons, and also act between neutrons and neutrons. Correct? Now that there is a question that, for example, in this nucleus, we have two protons. These protons are positively charged, both the protons. So, like charges will always repel each other, but still they are staying inside this nucleus only. Why? Is because of very strong nuclear force. This strong nuclear force is much stronger than the electromagnetic repulsion between them. You understand? Like you are two kids, okay? You are fighting with each other, but your parents are forcing you to stay in the same room. Okay, you are fighting with your brother. Kids are fighting, I don't like you, I don't like you. But there is a bigger force, the force of your parents, that tells you that however you dislike each other, at night you have to sleep in the same bed. That way, the force of this, the strong nuclear force, is so strong that it is overcoming the electromagnetic repulsion. But if this proton just comes out here, no, then the attraction will take place. Then the strong nuclear force doesn't occur. How is it? For example, you kids are going out in the garden, okay, and now your parents are not seeing you. Then you will fight there and hit your brother or sister. That means the range at which the strong nuclear force is active is very, very small. It acts in the order of 10 raised to minus 15 meter. That is the radius of the nucleus. So though being strong, it is not a long range force, but it is the strongest of all the forces. And this weak nuclear force is very, very rare. It is not found everywhere. Okay, it comes only in some radioactive reactions like beta decay. I will talk about all this in consecutive lectures. Just have to understand for some time that there are some reactions that takes place in nature because of some instability inside the atom, and then at that point there are some forces that comes. For example, again I'll give you the example of your own family. If in your family there are some ups and downs going on, somebody's health is not good, or somebody is not doing well in the school, not performing well in the exam, then there will be some shouting, howling going on, which is not common, but it is there sometimes. Similarly, this kind of weak nuclear forces are also there during some of the nuclear reactions. Okay. So, I have told you about the 4 forces of nature: electromagnetic force, gravitational force, strong nuclear force, and weak nuclear force. Now, there is some other things that we have to understand before concluding this lecture. We know that when we study physics, what we do is we look at, for example, there is a floor and a ball is rotating, doppling, playing with it, and it is coming to you. Okay, from here one man is standing and throwing the ball, and then there is one other man who is standing here and trying to catch the ball. Okay, what this man will do, he will look at the ball, look at the size of the ball, shape of the ball, the speed, the distance, and do some calculation in the mind, and then he will know that where should I stand, how should I stand, how should I keep my hand to hold this. All these calculations are being done. Similarly, in physics also, we see the experiments, we see how the experiments are behaving, and we do some other calculations, and then we come out in form of some equations. Some equations we come, and in these equations we find that there is some, say, x plus y minus x raised maybe x plus y minus z plus n whole divided by m. Some equations you randomly generate, and you find that there is some quantity, say m, which is constant throughout many equations. So what you do is, this quantity you give them name as constants. Like we have gravitational constant g, we have gravitational acceleration g, okay, and we have many other physical quantities that may remain constant during any physical phenomena. So what are these quantities that remain constant? There are few quantities that we know they remain constant in most of the cases. First of all, we have energy. But the energy, when I say it is the total energy in the universe, will remain constant. which is nothing but law of conservation of energy. Correct? Okay. We have another quantity, that is linear momentum. You have law of conservation of linear momentum. Okay. You have angular momentum. Angular momentum. We have law of conservation of angular momentum. Now, you should not be afraid at all when I am using all these big words like momentum, linear, angular, because this is just your first step. Today, I am just introducing you to some features, or you can say it is just a trailer of a movie. And slowly, we will develop an attitude to study physics, study nature, and come up with new ideas. I hope you like this chapter. Thank you.